Like I said in the problem of the day, today we're going over part 2 of section 5, which is logarithmic equations. And a logarithmic equation is an equation that includes one or more logarithms involving a variable. So we're going to get right to it with some examples. So solving a logarithmic equation. Our first example, we have what is the solution of log of 4x minus 3 equals 2. When we're solving logarithmic equations, we want to write these in exponential form. But we're missing something in this one. We don't have a base, which means this is the common log, which means that our base is 10. So anytime you have a log without a base, you can assume that the base is 10. So if we rewrite this in exponential form, it's going to become 10 raised to the second power equals 4x minus 3. Now we just have an equation with one unknown that we can solve. So 10 raised to the second power becomes 100 equals 4x minus 3. To isolate our variable, we're going to add 3 to both sides. So 103 equals 4x. Last step to solve for x, divide both sides by 4. And we have x equals 103 over 4. Or if you plug it into your calculator, you get x equals 25.75, and that is our final answer. For the second example, we have what is the solution of log of 3 minus 2x equals negative 1. Again, this is the common log, so we can assume that our base is 10. Rewritten in exponential form, we have 10 raised to the negative first power equals 3 minus 2x. 10 raised to the negative first power we can rewrite as 1 over 10 equals 3 minus 2x. From here to solve for x, we're going to subtract 3 from both sides, so 1 over 10 minus 3 equals negative 2x. 1 over 10 minus 3 becomes negative 29 over 10 equals negative 2x. Last step to solve for x, we're going to divide both sides by negative 2. On our left side, rather than dividing a fraction, we're going to multiply negative 2 into our denominator. That gives us the same thing. So we have negative 29 over 10 times negative 2, which becomes positive 29 over 20 equals x. And that's our final answer. Our next example is a little bit different. So we have log of x minus 3 plus log of x equals 1. This one's a little bit different because now we have two terms with x. We can rewrite this using the product property as log of x minus 3 times x equals 1. To simplify, we can distribute, so we have log of x squared minus 3x equals 1. Now we just have one log. We can rewrite this in exponential form. Our base is 10, so 10 raised to the first power equals x squared minus 3x. 10 raised to the first power is just 10 equals x squared minus 3x. Now you'll notice this is a quadratic equation. To solve our quadratic equation, we want to move all of our terms to the same side. So this becomes 0 equals x squared minus 3x minus 10 after subtracting 10 from both sides. From here, we can try to factor. We're looking for two numbers that multiply to negative 10 and add up to negative 3. Those two numbers, when we factor, are negative 5 and positive 2. So this becomes x minus 5 times x plus 2. By the zero product property, we can set everything equal to 0 and solve, so we get x equals positive 5 and x equals negative 2. So we have two solutions for x. But if we think back to our rules for logs, we always have to have a domain of all x values greater than 0. We can't have a negative log. So if we have x equals negative 2 and we plug back into log x here, that gives us a negative log, which can't happen. So negative 2 is an extraneous solution. And our only Oh, it's extraneous. Sorry, can't fit that S. So our only solution for this problem is going to be x equals 5. Our next example. What is the solution of 6 minus log 3x equals negative 2? So first step, we want to move all of our terms to the same side. So I'm going to subtract 6 from both sides. So we have negative log of 3x equals negative 8. Now we're almost ready to start, but we have this negative. So to get rid of it, we're going to divide both sides by negative 1. So this becomes log base 10 of 3x equals positive 8. Now we can rewrite this in exponential form as 10 raised to the 8th power equals 3x. To solve for x, we're going to divide both sides by 3, and we get x equals 10 raised to the 8th power over 3. This is going to give us a very big number, so you can just leave it like this for your final solution. Our next example is a bit of a challenge, so if you want to try this one on your own, take a second, pause the video, and get working. So we have 6 minus log base 5 of 3x minus 2 equals 4. First thing we want to do is subtract 6 from both sides. So we have negative log base 5 of 3x minus 2 equals negative 2. We almost are ready to start, but we need to get rid of this negative also by dividing both sides by negative 1. So now we have log base 5 of 3x minus 2 equals positive 2. So to solve, we're going to write this in exponential form. 5 raised to the 2nd power equals 3x minus 2. If we simplify, we have 25 equals 3x minus 2. To solve for x, we're going to add 2 to both sides. So we have 27 equals 3x. Last step, divide both sides by 3, and we get x equals 9 as our final solution. And our last example, for logarithmic equations, we have what is the solution of log base 9 of x minus 6 minus log base 9 of x equals log base 9 of 2. So our two terms here, we're able to rewrite using the quotient property. So we have log base 9 of x minus 6 over x equals log base 9 of 2. You'll notice in this equation, we have the same exact base on both sides of our equal sign. Remember, if you have the same base, that means these terms have to be equal to each other. So to solve this, we can write x minus 6 over x equals 2. So we're working backwards from what we did with exponential equations. With exponential equations, we added this log to both sides. Now we have that log, so we're able to just set our terms equal to each other and solve. So we have x minus 6 over x equals 2. To solve for x, we're going to multiply both sides by x first to get this out of our fraction. And we're left with x minus 6 equals 2x. Subtract x from both sides, so we have, if we go back, this is x plus 6 here. So x plus 6, and this becomes plus 6. So we're finishing with x plus 6 equals 2x. Last step to solve for x, we're going to subtract x from both sides. And we get 6 equals x as our final answer. And then we are done. So that's it for section 5. Your homework is posted in Google Classroom. It's a logarithm worksheet. It goes over exponential equations and logarithmic equations. Continue working hard. If you have any questions, feel free to reach out at any time.